You are watching Physics Exam Prep. The way we solve problems here is structured on purpose. It's backed by cognitive science, and it's proven to boost your study performance. Over the next series of lessons, we'll start exploring a new topic, forces and momentum. In this lesson, we're going through a medium-level Newton's second law problem. Many students drop marks on this question, especially when they're just starting to study Newton's second law. I would suggest you give it a try on your own first, just as a quick skill check. A quick sketch would be helpful for this question. If you don't get it, no worries. I will take you through it step by step. Alright, let's compare the sketches. I've drawn two diagrams. The one on top represents the block before the applied force labeled F1 is doubled. The one below shows the block after the force labeled F2 is doubled. The resistive force, the small f, stays the same in both cases. I've defined the right as the positive direction. It's quite obvious that this problem is testing our use of Newton's second law, because we see the keywords mass, force, and acceleration all over the place. Then comes the important question. What is this force, F, in this equation? Is it correct to plug in 4 newtons or 8 newtons directly? Some students try it this way and lose marks. That's because the F in Newton's second law is not just any single force. It must be the net force. And it is calculated by the vector addition of all the individual forces on the object. In this problem, we need to use the individual forces F1, F2, and the resistant force, small f, to calculate the net force on the block. Next, let's think about the general problem-solving pattern for this kind of before and after question. Most of the time, you'll be given two cases that involves the same physics event and the same equation, but with one or more quantities changed. The trick with before and after problems is always the same. Write the two cases out. Use the before case to work out the unknown, then substitute that straight into the after case. Alright, logic chain. Here is our roadmap. First, apply Newton's second law to both before and after cases. Then determines the net force from the individual forces acting on the block. From the question, we know F1, M, A1, and on the right, F2, M, and we need to look for A2. What do you think might be the next step? Yes, we get the resisted force, small f, from the before case. Then plug it into the after case. Then we can get A2. Pause here if you'd like to try the problem yourself before moving on. The solution part. Let's start with the before case. Write out the Newton's second law, F equals to ma. Then write out the individual forces contributing to the net force. Plug in numbers and calculate the resistive force, and then do the same setup for the after case. Write out the net force expression and substitute in the resistive force we just found, and calculate the acceleration A2. Let's have a quick recap. In this lesson, you learned how to use Newton's second law, F equals ma, appropriately. Remember, always plug the net force into F. Next, we covered the general problem-solving pattern for the before and after type of question. You'll see more of these in later videos, and I'll make sure you're ready for this type of question in the exams.